Hey guys, what's up? And in this video, we'll write our first few lines of code in Pytorch. The aim of this video is to identify tensors, what they look like, and convert between NumPy arrays and tensors. Convert to and fro between them because sometimes it's useful. But overall, our aim is to look at some common operations between NumPy and Pytorch. So we look at an operation or function NumPy and we'll see a function in Pytorch that does the same thing. So it's better to use the Pytorch function because it's GPU optimized. If you're using a deep learning, if you're working on deep learning implementation. So let's begin. So I will begin by creating a NumPy array of zeros, bunch of zeros, 10 zeros. So I'll print A and the type of A. So here we can see that A is an array of size 10. It has only zeros in it, and it's a NumPy array. Makes sense, yeah. Now let's switch to Pytorch. So this is the first page in the Pytorch documentation. I'm starting by reading the documentation because at some point you'll have to read the documentation, so why not start with it. So this is the very first function in the Pytorch documentation, in the entire documentation. It's the first one, and it's the first thing that comes up when you open the Pytorch documentation. This function checks if the object input to the function is a tensor or not. So let's check if the NumPy array A is a tensor or not. Of course it's not, right? So it should give false, and it does. It does give false. So that's happening because it's not a NumPy array. So what do we do next? The thing we should do next is, okay, let's create a NumPy, let's create a tensor and see if this function says that the tensor is a tensor or not. So to do this, we'll use another function from the NumPy library, and this one's called torch.zeros. Should be here somewhere. So basically what I'm trying to do is find, yeah, here it is. So yeah, so here it is, torch.zeros. So basically this is the identical function in Pytorch. This is the identical function to the np.zeros in Pytorch. So let's say torch.zeros 10 print b. It's a tensor of zeros, right? So let's check if b is a tensor. Oh yeah, it's true. The tensor b is a tensor. So we saw that there is a function called np.zeros, and there is the exact same a function that does the exact same thing but gives you a tensor. So why not use this instead of first creating a NumPy array and then converting the NumPy array to a tensor? Oh, by the way, we didn't look at how to convert a NumPy array into tensor. So the way we can do that is just do something like torch.tensorA. So this converts the object inside A to a tensor. So let's call it double A. And now check if torch.tensor. So is double A? Is it a tensor or is it not a tensor? It is a tensor because you converted the NumPy array into a tensor. So this is a way to convert NumPy array to tensors. Now let's say B is a tensor, right? Let's say I want to convert B to NumPy array. So how do I do that? So okay, I think this is a bit misleading. Let's do this. Yeah, and then let's convert, and I'll just put it here, and then let's convert B to NumPy array. And the way to do that is just use a simple command like this, b.numpy. That's it. Now print b underscore numpy and print the type of b underscore numpy. Okay, so this converted a tensor to a numpy array. So it's really easy. The conversion, interconversion between numpy array and Pytorch tensors are really easy. So if you happen to not be able to figure out a function or find a function in Pytorch that does something in NumPy, you want to do that thing, just do it in NumPy and just convert it back to Pytorch tensor, Torch tensor. That's fine. Or if you're able to find out a tensor that does that thing, or a torch function that does that thing, prefer that. Here are a bunch of functions in the torch library for tensors. Is the is tensor. So I think most of these functions, when you read through it, you kind of never use that, never use any of these functions. They're not useful because they Pytorch actually created a function or a method or for every class. Also tensor is a class of objects. So for every class they create a method which just supersedes the to need of all these functions in these basic functions. So what you can do here is that we know that B is a tensor. So instead of using this function Dodge's tensor2, just type B dot type, and this tells me that B is a torch tensor because it says dot type. It says it returns something. If I do A dot type, it returns nothing. It gives an array because A does not have the method called type, but B does because B is a tensor. So, and it also tells me that this is a float tensor. So this kind of you've done two things. You've found that it's a tensor. The object is a tensor, and it's a floating point number, and basically, yeah, that's all you need. And suppose if you want to convert B into a double, so just do B dot double, and now B it's converted into double. So it's double now. Torch dot float 64. You could also convert it into an int and do b dot int, and that's really easy. And you get a torch tensor with all its elements as integers. So these kinds of conversions are sometimes important because there are certain functions in Pytorch that input a certain data type, so you might have to convert between the different data types, and this is probably the fastest way. So yeah, I showed you some one function actually that has one function in NumPy and its duplicate function in Pytorch, and it's good to know that almost all functions in NumPy that are needed for deep learning are present in Pytorch, so probably better to use them. And we saw type conversion between NumPy and Pytorch arrays and converting between different data types. So this was the very basics of Python, and I hope, oh, did I say Python? This is the very basics of Pytorch, and I hope it was enlightening or refreshing or just a little better than boring.